Okay, so today we are going to talk about um, how HI is prepared in laboratory. So let's get started. All right. So you can see the how the apparatus is done right here. So let's just go right to the principle. Now, what it says that if you add um, iodine in with phosphorus, and it gives a resulting product. All right, it gives some product, and when we add water to it, along with some product, yeah, it gives some product. It will give us HI, and that's what we need. We need HI. All right, that's what we need. We need HI. So let's see how it goes. Before starting, let me tell you something that phosphorus has two valency. It has either 3 or either 5. It depends on the conditions. Alright, so P plus I2, that's the whole thing here. Phosphorus plus iodine. Now let's say when it has valency 3, so it's going to give us PI3, because iodine has valency -1. Iodine, it lies in chlorine, bromine, and iodine. It all has -1, and let's think about this as one, and that crisscross method. So let's just balance it. 2 and 3 and 2 and plus. Now it's balanced. So when phosphorus has valency 5, what's it going to give? A simple, all right, just simple method, Pi5. All right, now it has given us the product. Now we add water to it. All right, and let's see what happens. So Pi3 plus H2O and Pi5 plus H2. And I know this reaction is difficult, and a lot of you try to memorize it, and when in exam you might forget what the product is. The only product you remember will be HI, and it's sure that it's going to give us HI. And alright, so let's talk how can you determine this product, all right, without even memorizing it. So that's what I'm going to teach you. It's all logical. I don't know why people try to memorize it. Anyway, let me get off. Okay, whenever phosphorus is in product form and it goes through the reaction, its nature, it gets when it has 3, even when it has valency 3, it goes under valency 5. So that's what you need to remember. Then that's it. All right, so we have 5. 1 2 3 4 5, and it's Lewis dot method. It is very important. It's very helpful. It lets you determine a lot of reaction, how it goes. So we have phosphorus, and now as you can see in this reaction, we get H and I. So we can separate H and I with, if you put 3 right here, because you can see this. So 3 in H, we can separate this out, and the remaining product we'll have is phosphorus in the terms of phosphorus, hydrogen, and oxygen. So we need to see what kind of compound it does make. Alright, so we have 2 right here, and oxygen, it's more electronegative, so it wants to bond with phosphorus, so it bonds with oxygen. It's more electronegative, so, and we have oxygen. Now oxygen has -2. You need to know that. All right, so when bonding with one, it will have one negative charge, one. Now we know hydrogen has positive charge, so if you put hydrogen right here, the whole thing is balanced. So we just balance in this, so it gets cancelled out, and there you go. Everything in this is in neutral state. All right, neutral state. And let's see what kind of product it makes. We have 3 hydrogen, we have phosphorus, and we have 4 oxygen. Now that's what the product is formed. All right, now it gets in the terms of Pi5. What really happens right here is because there will be less amount of hydrogen, less amount of water in this first reaction, so The reaction that occurs in the first reaction is that, let me show you. So 1 2 3 4 5, we have our 5. So oxygen, as is very electronegativity, tends to, all right, and we have this bonding going on. So we have, I've already taught you this right up here. Now we have one electron. For one electron, we for this reaction, hydrogen bonds with this. So doing so, we will have product H3PO3, and that's it. I hope you get it. So our reaction will be Pi3 plus 3H2O plus H3PO3 and 3HI. Following with this Pi5 H2O, we'll get H3 PO4 and 5HI, and you can balance this whole thing. Okay, so I'm just looking how the balancing thing done. Alright, so there should be 4 right here. Alright, you can see there will be 4, and that's how the reaction goes on. And I hope you understand, you will understand this. So right, so this is the principle. And now let me show you the figure. This is the round bottom flask. We have phosphorus and iodine in here, and water is added from top so that the amount of water can be controlled. And now two types of gas gets liberated, iodine as well as HI, as is heating. So it passes to this delivery tube. Now in here we have moist red phosphorus for a reason. Now we only need HI. So this phosphorus, from this reaction, phosphorus absorbs iodine. So what the only thing that passes from this tube will be HI, and thus we have collected HI gas over here. And this is the laboratory preparation of HI. Now these are some languages. You understand it. And now there is still a question right here, why it cannot be prepared in the same way as HCl. Now it's a very good question. What this question is asking is that we know how HCl can be prepared with that a simple reaction, NaCl plus H2SO4 it's going to give us any H and Cl. We are going to get HCl. Alright, HCl plus Na SO4. Alright, we can get HCl easily by this reaction. Why can't we do same for HI? Why can't we react NaI plus H2SO4 to give us HI? So let's see how it goes. Alright, so we have the reaction for NaI plus H2SO4. Alright, so basically it will give us HI2 and Na2SO4. That's the basic of the reaction. Now H2SO4 will give us H2O. Alright, H2O plus SO2 plus nascent oxygen. This is how it goes. This is how H2SO4 gives product. Now we can see, now we have HI. Now we have nascent oxygen. HI reacts with nascent oxygen. Now we have hydrogen here, oxygen here. Usually when there is hydrogen and oxygen, there will be water. So to make this water, we need 2 HI, and we get H2O and plus iodine. Now when we combine all of this, when you combine all of this, what we actually get is that NaI plus H2SO4 reacting give us Na2SO4 plus water plus SO2 plus I2. There is no formation of HI in this reaction. And that's it. That's the laboratory preparation of HI.